Hi again, everyone. Before we move on to our next unit about fractional exponents, it's important that you know how to add or subtract fractions with like and unlike denominators. So first we'll look at fractions with like denominators. Since these are both 5 in the denominator, all I have to do is add across. 2 plus 4 is 6. And remember, when adding or subtracting fractions, the denominator stays the same. So we only add or subtract the numbers in the top while leaving the bottom alone. So 2 over 5 plus 4 over 5 equals 6 over 5. The same thing applies when we're subtracting. Since both of the denominators are 5, I will leave them alone. I just do 2 minus 4 over 5, which is negative 2 over 5. In our last two examples, the fraction answers could not be simplified, so we left them the way that they were. Here, I'm adding 3 plus 1, and that's going to be over 4, which means my fraction now, once I have added, is 4 over 4. Anything over itself equals 1, so you're going to have to simplify your answer to be 1. The same thing is true when you subtract to get a numerator over the same denominator. You have 6 minus 1 over 5, which becomes 5 over 5, which once again simplifies to 1. And as you'll see here, sometimes the fractions need to be simplified, but don't simplify to 1. So adding my numerators and leaving the denominator, we get 8 over 12. This is not the simplified form of this fraction. I can see that 8 and 12 will both be evenly divisible by 4. 8 divided by 4 is 2, and 12 divided by 4 is 3, so my simplified answer here is 2/3. Same thing when subtracting. 5 minus 3 over 12 equals 2 over 12. And since 2 and 12 can both be divided by 2, I'm going to go ahead and do that and get 1 over 6 as my simplified answer. Now let's look at the case where we don't have common denominators. Well, we need to change either one or both of these fractions so that the number in the bottom is the same for both. So here, 6 goes into 12 2 times. So in order to turn 6 into 12, I have to multiply it by 2. And since I don't want to change the original value of this fraction, whatever I do to the denominator, I have to also do to the numerator. And remember, when multiplying fractions, you multiply across the top and multiply across the bottom. So if I multiply 2 over 2 by 5 over 6, it becomes 10 over 12. Now, I'll add across the top and leave my denominator alone. Now I have 12 over 12, which we all know will simplify to 1. Now we're going to add 5/3 to 2/5. 3 doesn't multiply to make 5, so we're going to have to change the denominators in both of the fractions. Well, I know that 3 and 5 can both go into 15 because 3 times 5 is 15. So I can take my denominator from one fraction and multiply it to the other. So vice versa, over here, I'm going to multiply my first fraction by 5 over 5. So here we do 5 times 5, 25 over 5 times 3, which is 15. On the right, 2 times 3 is 6, and 5 times 3 is 15. So now we have a common denominator. 25 plus 6 over 15, which is equal to 31 over 15. And since 31 is a prime number, this cannot be simplified any further. So let's try another. Can you think of a number that's evenly divisible by both 5 and 2? If you came up with 10, that's a great idea. So 2 needs to be multiplied by 5 to make 10, and 5 needs to be multiplied by 2. 2 times 2, 4, 2 times 5, 10, 3 times 5 is 15, and 2 times 5 is 10. So this equals 4 plus 15 over 10, or 19 over 10. I can't simplify, that's the final answer. So I can see that 4 times 2 would give me 8. Another way to tackle a problem like this is I can divide both of these terms by 2 and still have a common denominator. So I'll leave the left side alone. 6 divided by 2 is 3, and 8 divided by 2 is 4. So now I still have a common denominator. 2 plus 3 over 4, or 5 over 4. This same process will be used when we're doing subtraction. Just get a common denominator and then subtract the numerators. So here we can either multiply our left side by 2, so we'll have 10 in both denominators, or we can divide our right side by 2, and we'll have 5 in both denominators. So I'll show you both ways. 5 needs to be multiplied by 2 to make 10, or I can divide this fraction by 2. 2 divided by 2 would be 1, and 10 divided by 2 would be 5. So this process is actually a little bit longer since you're going to have to simplify at the end. 2 times 3, we get 6 over 10 minus 2 over 10, or 4 over 10, and that simplifies to 2/5. When I do it this way and get the smaller denominator, I don't have to go through the extra process of simplifying, and my answer is just 3 minus 1 over 5, or 2 over 5. I don't care which way you do it as long as you're getting the right answers. So for our final example, we need to come up with a number that's evenly divisible by both 7 and 5. And that number will be 35. So I'll take the 5 from the left and multiply it to the right, 5 over 5, and then do the same thing with 7 over here. Multiply across the top and the bottom. 7 times 4 is 28, and 7 times 5 is 35. Minus 3 times 5, 15, over 7 times 5, which is 35. 28 minus 15 gives you 13 over 35. So now we're going to take a look at how these rules are going to apply when we're combining rational exponents. So remember, if I'm multiplying, that means I add the exponents. So it's x to the power of -3 plus 2 over 5. So I'm just not going to touch the x right now and deal with adding my fractional exponents. I have -3, and I have to add that to 2/5. Well, when I have an integer whole number, the denominator is actually a 1. So I want to make both of the denominators 5. So I have to multiply 1 by 5 to make that happen. So -15 over 5 plus 2 over 5 is -13 over 5. And don't forget that that was actually the process we need to find the exponent of our simplified expression. So my answer is x to the power of negative 13 over 5. So we have seen a problem like this before. Remember when we have a negative exponent in part of the fraction, that means we will move it to the other part of the fraction and change it to be positive. And 1 times anything will be that thing. So if I multiply x to the positive 3 over 2 by 1, I'm just going to have x to the power of positive 3 over 2 as my final answer. So just as when we're multiplying, we add the exponents, and we're dividing, we subtract the exponents. If I don't see an exponent, remember that exponent is 1. So this becomes a to the power of 1/4 minus 1. So here you also want to have a common denominator so you can subtract the fractions. 1/4 minus 1. And whole numbers are over 1. I'm going to multiply this by 4/4. So we get 1/4 minus 4/4. Anytime you need to replace a 1, you can replace it with the denominator over itself, because we know that anything over itself is equivalent to 1. So this will simplify to negative 3/4, and that's going to be the simplified exponent. So we have a to the negative 3/4 power. And another exponent rule we need to remember is that when there's an exponent on the inside and an exponent on the outside, we multiply them together. Multiplying fractions is easier than adding or subtracting them. Negative 1/3 times 4, this is 4/1, so just multiply across the top and multiply across the bottom. Negative 1/3 times 4/1 equals negative 4/3. And that will be the exponent for my final answer. Final example is z to the power of negative 2/3 over z to the power of negative 1/5. My first step is to be switching these positions and changing those exponents to positive. So z to the 1/5 will move to the top and become positive, and z to the 2/3 will move to the denominator and become positive. Now it's division, so we have to subtract our fractional exponents. So I have a denominator here of 5, a denominator here of 3. We want them to be the same, so I'll multiply the right side by 5/5 and the left side by 3/3. Here I have 3/15 minus 10/15, which is negative 7/15. So the final answer here is z to the power of negative 7/15. So don't forget that while you're doing your homework, if you have questions about anything or are struggling, you should make a note of them and come to my office hours where I can help you. Have a good day.